Now the next speaker is Phil Bell, and he's the brother of Mike Bell, who I profiled on the Chathams. And Brian Bell was the Director of the Wildlife Service, so threatened species are in these guys' genes. And Phil is the business manager at Zero Invasive Predators, which we set up with Next Foundation. It's got Mike Slater and Devon McLean on the governance board, to actually take a group of staff out of DOC. This is DOC's first startup, really. And we took a number of people out of DOC and said, we'll put you in this new entity called Zero Invasive Predators. And your main task is to work out how do we keep, as we get parts of New Zealand rid of pests, how do we keep them from coming back without creating fences? And when I went to the board meeting last year and met my staff who were in that, they said, this is the proudest time of their career because they're no longer part of this DOC monster of 2,000 people. They've got their own structure. They're singly focused on a purpose. They're not having to go to staff meetings with the Director General. They're just focused absolutely on how we get rid of pests and keep them out. So ladies and gentlemen, Phil Bell.
Okay, yeah. I'd just like to add to what Lou said. Some of the people yesterday were talking about how do we bring others along. This is my normal. So this is kind of what I talk about at dinner and that, so please excuse me if I get a little bit crazy because I'll just think I'm normal. So I'll just take a step back and talk about who Zip are, just for those of you who don't know who we are. As Lou mentioned, we were funded by Next and DOC, and this was the purpose that we were set up for. In essence, there's kind of three main areas that we focus on. One is the complete removal of the predators in the first place. The second part is defending that line, so stopping things getting back. And then the third one is detection and response, so the things that do get through that barrier, how do we detect them and then how do we crush them? Today I'm just going to focus on the removal part. If you want to hear about the others, there's about 70 odd projects we're running, and I can tell you about them later. But when we set out, we thought this was the easy one of the three. And this is kind of why. We've been doing this basically since people said it couldn't be done. And so we've kept doing it. We've been doing it for 50 odd years now. Unfortunately for us, the tool that we use, and the most successful tool probably ever in conservation, aerial bradifacoon, cannot just be picked up and chucked onto the mainland. So we can't take the technology that we've already developed and just whack it on the mainland and get the job done. We needed another tool. So what we wondered about, and it's at the same time that a few others in this room were thinking about it too, so I'm not going to claim it as our own idea, was whether aerial 1080 could be that tool. So we were well aware of the fact that it's an acute toxin and therefore there's potential for learned bait aversion. We were also well aware that the literature is pretty mixed and some of that early stuff doesn't really apply anymore because there's been a whole lot of advances, particularly things like pre-feeding and whether you can actually re-teach animals that food is good again. But when we looked at it, we sort of thought, what do we need to do to know whether this is the tool that we could take forward? The really cool thing is, if it is the tool, we don't have to do anything more. This tool is registered. We could pick it up tomorrow and operationalize the new technique. So for us, it was worth having a crack at, even if the risk was high. So then what did we do? We certainly started out not being experts in 1080, so we started by getting the recognised experts in 1080 from across DOC, from TB Free, from Land Care Research, and we got them into a room and said, if you were to design a trial to have a crack at getting rid of everything with aerial 1080, what would it look like? And basically they designed this design here. And so what it is basically we doubled up everything that a standard 1080 operation does. We doubled the sowing rates, we doubled the amount of pre-feeds, and then we also built in a provision that if we found survivors after that first operation, in a couple of months' time, we would go back and do it all over again, but this time with a different bait to try to teach them that food was good again. So, where we did this was on Taranaki Maunga, so I want to acknowledge the local dock team who picked up a massive amount of work when we came to them with this trial, but also the Taranaki Maunga board, who were super supportive and really into this idea. At the time, middle of last year, the Taranaki Maunga project was just getting off the ground, and DOC was beginning planning their operation to 1080, the entire Egmont National Park. So the timing worked out really well that we could come along and stick our trial right in the middle of their operational area. So the photos on the left-hand side there are basically just telling you where Taranaki is if you're not from New Zealand. There's the beautiful circle that Lou alluded to about Taranaki, and then those shapes are our trial. So our experimental block was the blue diamond. We treated 1,600 hectares and then intensively monitored the 400-hectare red diamond in the middle. And at the same time, we also set up an intensively monitored 400-hectare block, that's the pink square, inside the DOC operation to understand how close does a standard operation get compared to what we were going to have a crack at. I will say that we intended to only do 2 pre-feeds in the first phase of our operation. Unfortunately, the weather was absolutely horrendous last winter, and we needed to keep all the animals keyed on and also be able to key on any new individuals, juveniles that came into that population. So we ended up using 4 pre-feeds before the toxin went down in early December. So, how did it go? Well, inside our intensively monitored block, in which we set up a grid of 100 by 50 with various detection points, so we ended up with about 1,300 detection points running continuously for 7 weeks. This is all we found over that entire 7 weeks. So on the left-hand side, you've got the total possum detections, of which there was 1. And then on the right-hand side, you've got the total rat detections over that 7 weeks. Now, we're pretty confident that that possum was the only possum in there and that it actually left again. The reason for that confidence is that amongst those detection points were a whole heap of cameras that didn't actually see it ever again. What I will say is, interestingly enough, it took 21 days after the toxin before we found that possum. It took us 33 days before we had the first rat detection. So there is something going on there about potentially a bit of shock to those animals that makes them a little bit wary. However, based on the effort we put in, we're pretty confident that we achieved our goal of functional extinction for possums inside that block. Obviously, we were a wee ways off for the rats. And I mentioned the comparative block. I'll just put that up there. That is basically what we saw in the block of the standard DOC operation. Yeah, quite a bit different. So given we had a relatively small number of surviving rats, we decided rather than kicking in with the second phase of a full aerial treatment, that we would target those individuals that were left with live trapping. However, we wanted to make that a little bit crazy as well. So what we did is we aerially pre-fed the entire block again, and then we set up our live capture traps for rats in the areas where we had those detections so that we could minimize the amount of effort we had to put in. But then inside those live capture traps, we wired in the toxic version of the pre-feed. So we had the toxic bait as the bait inside the trap, and the animal had to chew it to set the trap off. The whole point of that was that if the animal was totally not averse to the second hit of toxin, we would see this when we came to the trap. And then to double up what we were seeing, we made sure that we had a truckload of cameras on all of these traps just to know that we could see when the animals were eating things and just to know, whether they were averse or whether they were just really, really hungry and they needed to eat something. And this is what we caught in our live capture traps. The pink means that they're female, the black means that they were male, The skull and crossbones means they were dead when we came to the trap, and the rat body means they were still alive at the time. Basically, what we got was we caught 13 of what we're terming survivors, so animals that would have been present on the Maunga when 1080 was put down. 6 of those were dead when we got to the trap, meaning they weren't averse at all. 2 of them were what we termed walking dead, so our field team are very experienced in running toxin trials, so they kind of know what a dead animal is about to look like before it dies. So they determined that 2 of the animals were on their way out, and then 5 of them were still alive. I've termed that as potential aversion because they still went into the trap and bit on the bait in order to set that trap off. What we don't know is whether getting caught in that trap then made them get a bit freaked out and stop doing anything, or whether it was the bait itself. Interestingly enough, we caught 5 other animals that we've termed as offspring. Now, we've based that entirely on the developmental age that we've learned through both the literature and through our rat breeding down in our captive facility at Lincoln University. And so these animals would not have been present at the time the 1080 went down, so it's not really that surprising that they weren't averse. I will say, interestingly enough, one of these offspring indicates that within 5 days of putting the toxin on the hill, 2 survivors found each other, bred, and produced a litter. So we're running that close to the wind with this technique. However, we thought these results were pretty awesome, and we are super, super encouraged by them. So we're pretty happy that we're not completely crazy that thinking that this might be a good idea. What we are being now is pretty bloody ambitious, to be perfectly honest. We are running 2 of these trials right now in 2 different locations to just check that what we saw on the Maunga is actually what's going on. And we believe that if we can pull it off, if we can pull off complete removal over these blocks using this kind of technique, that we have a tool that we could take to forested areas of New Zealand and begin rolling out some of our removal operations. The really important thing for us is we think this also changes the 1080 conversation. So right now, that use of aerial 1080 is cyclical. We're there every 3 to 5 years because the animals breed up again. We believe that if you can go to a community and say, we want to use aerial 1080, but we're going to use it once, and then we are going to lock down your site in perpetuity as a predator-free site, that is a much easier conversation to have than the one that we have to have right now, which is, we're coming again, the animals are back, we're coming again. And so what we need is we need to bank this technique so that we can start having that kind of conversation with New Zealand to drive the predator-free 2050. Thank you.